I would like to give you a short introduction to KiCad. KiCad is a PCB designer tool, and we will work now on a very tiny project with an Arduino and a temperature and humidity sensor. So the Arduino has a Wi-Fi module, as you can see here. You can see the antenna. So it's actually like called Node MCU or VMOS. It's not official Arduino, but it's using the Arduino platform. So we call it Arduino from now on. Then we will add this humidity and temperature sensor just to log some data, and then the Arduino can put this data to a server, for example. And then we will also add an LED. So here it's like 3 LEDs in one package. So this whole LED package can do red, green, and blue. And this we can do to just for indicating whether just the microcontroller, the Arduino, is working properly. Then it shows green, and when it has some errors, it shows red. So now let's go on. We open KiCad, and then we say new project, call it just temperature logger. Okay. We will put it in documents folder, save. Here it is. And then we will add one library. So this is the library of this temperature and humidity sensor. So in principle, we need to do two things. We need a schematic, which is in principle only the electronic wiring. And then we have the PCB layout. This will be the actual layout of the PCB. So let's go on with the schematic. So most of the parts are already, or some parts are already included in KiCad. Some are not. For example, the temperature logger, the temperature and humidity sensor is not in the KiCad software already, so we have to include it. This holds for the schematic, so like for the electrical symbol you will see in a minute, but also for the so-called footprint. This is like the, how to say, these are the dimensions you need for the PCB, but you will see later. So first add the humidity sensor. So go to symbol library. Go to where is it? Manage symbol libraries. Then you can say you can define some global libraries you want to use in more projects or only project specific libraries. So we want this to be project specific. Then we can add a library. So libraries for the schematic are .lib at the end. So library, then we press open, and that's it. So now we can place some parts here. So we can start with the Arduino. So we go on play symbol, press somewhere, and then we type VMOS D1 mini. Place it. Okay, next one. We just place our mouse somewhere we want to place the next symbol on. Click and say DHT22. This is our temperature and humidity sensor. So let's place it here. Then we need LED. So here we need RGB, LED RGB. Now we want the ground to face to the right for convenience. Okay. Then we add some resistors. So we type R. Then we can rotate it in a way that they fit here, but we can also place them somewhere else and wire them. Yeah. And Then we also need a resistor to connect the data line and this power line of the temperature sensor. This is just a pull-up resistor, which makes the data transmission more stable. So now let's start to connect the parts electrically. For this we use this button place wire, and we can start with this DHT22. Let's start with the power. We connect the power rail to 3.3 volts of the Arduino. Then we take the data line and connect it to D0, digital input 0. And for the ground, we could just connect the ground to the ground, but we will make it a little bit easier or more convenient. So we press this button. Then we can just get a ground symbol here. And we will put the same symbol here, and then they are in principle connected. Here. And then we need a ground for the LEDs too. Awesome. So let's do some more wiring. Yeah, we connect the LEDs to the Arduino, or let's say the resistors, and then we connect the other ones here to the ground. Awesome. I think that's it. Now we can also add some mounting holes if we want to mount the PCB later. Here, and another one. The placement is not super important. Yeah, we need this pull-up resistor, so we place another component, for example here, and wire it. So now you can in principle give names to the resistors, and you can give a value. So for example, pull up, typical value would be 10K, so 10,000 ohm. For these resistors, you can calculate it easily. So the Arduino puts out 3.3 volts. The diode drops, so the LED drops about, I don't know, 1.8 or 2, let's say 2. It will be different values for red, green and blue, obviously. So we need a resistor which drops 1.3 volts. And we want to limit the current for the LED to 20 milliamps so that it won't blow. And this is now the resistance we need, 65. Okay, so we can just go over the component, press E, 65, and here, 65. Okay. Now we could also specify here some things, or here some things, but it's not so important for now. So we can save. And now we have to assign these so-called footprints. So we just said it's a resistor, but we didn't say if it's SMD, so placed on the PCB, or if it's through hole, so like put through the holes. And it could be any kind of shape of resistors. So now we have to assign these so-called footprints. To do so, we go to Tools, Assign Footprints. Now it wants us first to annotate. Annotate means just auto-name these components. So it will put likely some numbers where the question mark is. We annotate. Then you can see it called the resistor R2, R3, R4, etc. So this is the assigned footprint. window. It's still loading some things. In the middle there will be the most important table. On the left will be the symbol. So this is the thingy in the schematic. This is a symbol. And on the right will be the footprint. So the actual look on the PCB. So let's assign LED. So on the left we have some footprint libraries. So we can go for LED. Okay, LED SMD. We want to place an SMD part there. And then we need a specific one. We need an RGB 50-50. So 5 times 5 millimeters. So double click. Then we need mounting holes. Okay, let's go. Mounting holes. Then we want to use M3 screws. So we use this 3.2 millimeter. Press. It jumps into the next row. Then we can press again. So now resistors. Let's find some resistors. So we want through hole. And we want them to be 6.3 millimeters in length. And let's say the 7.62 millimeter horizontal. So we press this 4 times, we have 4 resistors. And then we need this DHT22 temperature humidity sensor. So the symbol we had to add, we had to include the library. Now we have to do the same for the footprint. So we go on preferences, manage footprint libraries, project specific, and we just do the same. So we go into the folder, and then we have to find now a different file. And it's in the sensors.pretty folder. So it looks like this. It's KiCad _mod file. But it will find it automatically. So we just say here, okay. And now here a new category will pop up called sensors. And there we have our DHT22. So now all symbols are assigned. We can press OK. And now we can actually finally design our PCB. So we click the symbol, which looks like a PCB. And now we have to import the parts. This we can do with this symbol, which is like a like half schematic, half PCB. It says update PCB from schematic. And when it shows some red warnings here, it's usually because you didn't assign the footprints right. So let's say update PCB, close, and then it will put us all the components here. Next step is, now we have to just to position these components as we want them to be on the PCB. So we click on, for example, this mounting hole, and now it gives us a pop-up. It wants us to clarify the selection, because we could mean the text, but we could also mean like the whole mounting hole. We want to use the mounting hole, and then we press M for move. And we just like place it here, then take the other one, press M. Let's say we place it here. So I like the position of the temperature sensor. So now let's take the LED, press M, and we want to have the ground on the right side, just for convenience. Okay, this looks good. So now we have here different resistors. So we press M and then we can move them. Now you see these white lines. So this means that the white line connects the pins which we have to connect by traces later on. And now you see they cross. This is not nice, so we just rotate. Our part. And now we can just place it roughly on the height of the pin. So let's take the next one. Here we have the same problem. We rotate it again and place it. This one can go here. And this one goes here. So you can just place them as you like. Now we can start connecting them. So we can connect parts when they're through hole on the back and the front copper layer. And when they are like SMD, so surface mount, we can connect them on the surface. So for example, this LED is surface mount, so we just select front. And then we say root tracks, and we just press on this pin and connect it to the one which is highlighted. And we take the next one and the next one. Okay, so the last resistor is not rotated properly. So we just press escape for some times, select it, rotate it, and then we can reposition it. Great. Again, select the track tool, and we can just connect them. So this goes here, this goes here, here, and this wants to go there. This wants to go here. Then we have some grounds here. We can also click, then it makes like a stop there. And so with an easy PCB, this is pretty nice and convenient process. When your PCB is a little bit more complex, then also the routing is getting, can be super intense, let's say. Now we want to connect, for example, this ground to this one, but the problem is that there are some like red lines in the way. So yeah, so it's not super nice. And I want to show you how to route on the other side of the PCB. So we can just press V. Sorry, no. Let's do something else first. So here we go on the back plate. Select this routing tool again. Now you see that the trace is green because it's on the back plate. Okay. What we can also do is we can switch from the front to the back plate just anywhere we want. So let's do this. For example, here are some red wires in the way. So we start with green. And for whatever reason, we want to go now to the front side, to the front copper plate, just because of some reasons. So we press V. And then we can make a so-called via. So this will be a connection from the bottom to the top, and vice versa. Left click, and then it automatically switches to the traces on the front, which are red. So we are lacking only this pin here, and we connect them, and that's it. So everything is wired, looking good. Now we can change what's written on the silk screen, for example. So here, everything which is like turquoise, green, bluish can be, will be seen on the PCB, will be written on the PCB. So let's change this text. We select it, press E. Then we can say Arduino. Amazing. For the mounting holes, we don't need any description. So we press E and deselect this visible checkbox. We do here the same, press E, visible. Okay, good. Then we have here our LED. And then we have all these for the resistors. So we can just place them inside the resistor. This will be this DHT thing, temperature sensor. We can put the description there. This we can place here, and this we can call DHT22. Okay, this looks good. Now we have to mark our outlines. So where should this PCB be cutted? So for this we go to edge cuts, and then this tool here, add graphic lines, and we just make some outlines as we like them. Okay, so if you press a key, so on the Mac it's the Command key, maybe on Windows it's Alt or Control, then it makes like straight lines. Okay, now we have our edges. What we could do now is add, for example, some text. So let's do this. So we go to the silk screen again. So it's F silk, front silk. We can just place some text. And put it here. So now it's, in principle, now we're done. Just one good practice is to put so-called, what do you call them? Like ground planes, maybe, all over the PCB. So now we have these traces, but the rest of the PCB is just empty. There's no copper, and it's like, it's common to make everything else a ground plane. For this we go onto the symbol here, add filled zones, and then, we have to select the front copper plate, and then it will ask us what we want to connect this big area to. So we want to be ground. Say okay, and then you can just make some very rough outlines. So everything now is, so everywhere where there's no trace is ground. So here's some black area because it's not just, it's like not accessible, and but it's not so important for now. Now we do the same for the back. We can make the front layer invisible, and so I was just warning that my hard drive is almost full, out of space. So we do the same again. Say ground. Sorry again. So yeah, we can just say close line, and then we have the ground plane here too. And that's it. We press Command S. Then we can go to a PCB to a PCB manufacturer. So I picked Iceland's, just German brand, and I will select the PCB we just created. In principle, I just selected this file here, .KiCad PCB, and there it is. So here's the area where the Arduino goes. Here's the copyright, here's the LED, here are the resistors we need. Here's the this temperature sensor, and as you can see, there's no trace for the ground because it's directly connected to this plane. So now we can also turn it and see the backside. If you would like, you can also see a 3D view. And in principle, that's it. So if you have any questions, feel free to ask. Bye bye.